Well, hello everybody. This is lesson 6 of the year, or lesson 3 in this unit 1B. We are doing solving absolute value equations. So this is something that you probably have seen before, but we need to remind you of that. So to get started, let's do kind of the steps we're going to do. We're going to do something a little bit different, but I think it'll make life a lot easier for you. The absolute value of number, remember, is the distance from 0, so it's always positive. It's represented by the 2 bars, and we actually, if you remember, we graphed it. If we would graph the absolute value function, it would be a V. Okay, but we're solving equations, no graphing in this unit. So to do this, we're going to make sure we do a few things. So we want to make sure we isolate. I guess we need to get a pen. So we want to isolate the bars, okay, and if the bars are not isolated, we're going to substitute U in for the bars, okay, and you'll see here as we go through this why this makes it a little bit easier. So once we substitute U in for the bars, then we're going to solve for U. And then U is isolated, and you've solved for U, so we're going to replace U with the bars. We're going to put them back in. Then after that, we're going to split into 2 simple equations. Okay, then we're going to solve, and then we're going to check our answers. Okay. So the first couple of examples are just pretty easy. So if you do this, we're going to split this into 2 because the bars are already isolated, so I don't need to substitute U in. So we're going to get x equals 10, so you're going to split them into 2. You're going to copy the first one down. The second one, though, is x equals negative 10. Because if I take the absolute value of negative 10, I also get 10. And if I take the absolute value of 10, I get 10. So we're going to write x equal 10, comma, negative 10, and that would be my answer. Okay, the next one's going to be the same. We're going to go z equals 2/3, and z equals negative 2/3. So z equals 2/3, comma, negative 2/3, and that would be my answer. This particular one is actually, I want to come back a little bit, is actually the empty set, or no solution. Because if you look, the bars are isolated, but the absolute value of m can never, ever be a negative number. So if you get the bars isolated and you have a negative number, then we know we have no solution. However, if you put the numbers in after you get done solving and check, you will find out you will get false answers or false statements, so therefore that would be no solution also. Okay, so let's go ahead and move this up a little bit. Oh, flipped it around. Okay, so what we're going to do is we're going to solve, and then we're going to also check. Okay? So the first one, if you notice, the bars are isolated, so therefore I don't need to put U in because they're already isolated. If I put U in for 2x minus 1, the absolute value of it, I substitute it right back in. So once you got to do that, you just split them. So you're going to copy the first one down as is, and then you're going to copy the second inside as is, but it could also be the opposite. So the opposite of 5 is negative 5. So we're going to add 1 to each side. So I get 2x equals 6, 2x equals negative 4, and we're going to divide by 2, and I get x is 3 or negative 2. So now I got to go over and check. So when I go over and check, I'm going to substitute 3 in first. So I get the absolute value of 2 times 3 minus 1. Does that equal 5? Well, that would be 6 minus 1, which is 5. The absolute value of 5 is 5. So that does check. Then we're going to do the same thing with negative 2, so I get x is negative 2. We're going to see if that's correct. So when I do the same thing, I get 2 times negative 2 minus 1, and we want to know if that equals 5. So that would be negative 4 minus 1. which is the absolute value of negative 5, and the absolute value of negative 5 does equal 5, so the check works. So we know that my two answers are correct. Okay, we're going to go ahead and go down. Now we're getting to a point where we do not have the u isolated. Okay, so see how there's a negative 5 with the u? I'm sorry, let's go back. We do not have the absolute value bars isolated. We have a minus 5 on the outside of them. So what we're going to do is we're going to set, I'm going to put it off in green, we're going to set u equal to the absolute value of a minus 4. Okay, now, second step is then we're going to substitute u in for that, and we're going to solve this equation. This goes back to middle school equations, so this is much easier to solve. So we're just going to add 5 here, so I get u equals 5. The u is by itself, so what we're going to do then on the u, let me rewrite this, it's kind of sloppy. Okay, we're going to now substitute the a minus 4, the absolute value of it, back in. So a minus 4 goes back in, and that equals 5, and then we're going to split it into 2. So I get a minus 4 equals 5, and a minus 4 could be equal to the opposite of 5, which is negative 5. Add 4 to each of these sides, so I get a is 9. And negative 1. So now what I got to do is I got to go back and I need to check to see if those two fit or work. So we're going to do a equals 9 first. So the absolute value of 9 minus 4, take away 5, does that equal 0? Absolute value of 5 minus 5, does that equal 0? And 5 minus 5 does equal 0, so that works. Okay, we're going to do the other one for a equals negative 1. So negative 1 minus 4, take away 5 equals 0. So I should say the absolute value of this. And absolute value of negative 5 is 5. 5 minus 5 is 0, so that checks. So I know that both of my answers are correct. Okay, let's keep going. So we're going to go down to 6, and now we're just going to get into more complicated equations. Okay, so the first thing we need to do is there's a whole bunch of stuff around my absolute value bars. So we're going to set our absolute value bars to absolute value of x plus 2. We're going to substitute the u in for that, and now we're going to solve. So when we solve, we're going to add 1. So I get 3u equals 9. We're going to divide by 3, so I get u is 3. So now we're going to come around and we're going to take the bars and we're going to put back in. So I get x plus 2, the absolute value of it equals 3. We're going to divide them. I get x plus 2 equals 3. X plus 2 could equal negative 3. We're going to subtract 2 from each side. So I get x is 1 or negative 5. Okay, so now we got to check them. You always need to check because some of these are not going to work out. So if I check x equals 1 first, I get 3, absolute value 1 plus 2 minus 1, does that equal 8? So 3, absolute value of 3 minus 1 equal 8. 3 times 3 minus 1 equal 8. And 3 times 3 is 9 minus 1 does equal 8. So we know that one's correct. Well, what about negative 5? Let's go negative 5. We've got to check that. So you get 3, negative 5 plus 2 minus 1 equal 8. So you get 3 times the absolute value of negative 3, but the absolute value of negative 3 is 3. And you subtract 1, so I'm right back to where I was, and 9 minus 1 does equal 8. So my answers are correct. Okay? Okay, let's keep going. And it looks like we have just 2 more. Now, this one's a little trickier, so I need you to pay attention. Okay. So, first thing, if you notice, is the bars are already isolated. So since the bars are isolated, I don't have to use the u. but I have to split it into two equations. So you're going to copy the first one down as is, and the second one you're going to copy the inside as is, but you're going to switch or take the opposite of the other side. Okay, so see how I put the negative in parentheses? So what we're going to have to do is we're going to distribute, so I get 3x plus 2 equals negative 4x minus 5. Okay. Okay, so now I got to solve for x. Well, let's just go ahead. I'm just going to go ahead and move the right one to the left. So you get negative 4x. Oh, let's go back. That's not right. You get negative x plus 2 equals 5. Subtract 2, I get negative x equals 3. Divide by negative 1, I get x is negative 3. We're going to still move the one on the right over, so I'm going to add 4x. And I'm going to subtract 2, so I get 7x equal negative 7. X is negative 1. Okay, so I need to check. I'm going to fill it in and I'm going to talk through it because it looks like I'm going to run out of room. So we get absolute value if I check x is 3 first. So let's check x is 3. Absolute value of 3 times 3 plus 2, does that equal 4 times 3 plus 5? Oh, it's actually negative 3. Everybody put negative 3 in there. Okay, so negative 3. So 3 times negative 3 is negative 9, and negative 9 plus 2 is negative 7, and that equals 7. 4 times negative 3 is negative 12 plus 5 is negative 7. And 7 does not equal negative 7, so 3 is not one of my answers. Okay? Okie doke. Let's go to the next one. We got to check x is 1. So x equals negative 1, so we're going to have 3 times negative 1 plus 2. Does that equal 4 times negative 1 plus 5? Well, 3 times negative 1 is negative 3 plus 2. That's negative 1, which is 1. 4 times negative 1 is negative 4 plus 5 is 1, and 1 does equal 1. So x is negative 1 is my only answer here. Okay? Last one, I believe. Let's go ahead and go on up. And the last one is this. The bars are isolated, as you see. However, look here. Can the absolute value ever be a negative number? No, it can't. So the answer is no solution. Now, if you would actually go through and solve that, you would get two answers. You would plug them back in, and when you figured it out, they would both give you false statements. So therefore, that would be a no solution. Okay, that is the lesson on absolute value equations.